Never mind. Okay. What's your starting amount? 110,000. Now, interesting enough, this morning I saw somebody write a 1 there. Now, let's just think that through. The population, if the population started out as 1 person, and it's supposed to grow. Okay, I'm gonna let you think about that one. I was a little bit on the curious side. I was like, how's that gonna happen? All right, must be a different type of person. Okay, what is the value of the growth factor? 1.05. Right. If you're starting at 100% and you're going up 5%, that means you would be at 105% of what you used to be at. And then, of course, we're plugging in. That's for the first. And to get this one, what are we using for x? What are you using for x to find the next answer? 14, right? It says after 14 years. Okay, so we type on our calculator. I do need to make sure you know how to use your calculator to come up with this answer. I've seen several issues today, so. Did you get over 200,000? Okay, good. 200 what? Okay, there you go. Okay. Okay, if you point anything on this, that's gross. Okay, we're not cutting people up here, so stop. Sorry. If somebody chose to put 3, number 1, I know they did something illegal. They double rounded. They took the 4 and they saw the 7 after it, and they rounded it up to a 0.5. Then they rounded again. That's not correct. However, since really the point of this question is using the formula, not the rounding issue, I think I'd be okay. I'm not going to die over that. But double rounding is not accurate. So, just so you're aware. Okay? Now, in question 2, it says one type of uranium has a daily radioactive decay rate of 0.6%. If 20 pounds of this uranium is available today, now look here. They have given me the formula to use. They're not asking me to write a formula. They gave it to me. And it says, so this tells me how much remains after T days. What do you think we're going to plug in for the time? And let the time be 50 days. Okay? Now, what I have noticed when people are typing this in their calculator is that they are not putting parentheses right here. The blue ones right there. That's important. Okay? And so a lot of you, when you do your exponent, should be typing negative 0.006 times 50. Make sure that's in parentheses when you type this in your calculator, because we need to be getting the same answer. Your answer does need to be less than 20, because this is going down. Okay, you should be getting like 14.8. And if you're not, I'd like to know so I can help you type it on your calculator correctly. That's why I want everybody to practice.
We can't round it to 15.
If you round it to 15, it'll be fine. Okay. There's not a lot of work here that you need to show on question 2, so I'm not too worried about that. Okay, question 3. They give me an equation. The equation y equals 84,921 times 1.093 models the number of college students who study abroad each year from 1995 through 2006. So they gift wrapped the equation for you. My question is this. When you look at that equation, can you tell me the percentage increase? How much is this going up? Is it going up 93%? Is it going up 93%? Yeah, that might be a little high, but you're on the right track at least. Okay, so if we take a look at what we've talked about before, you start at 100%. We are stopping at 109.3%. Remember, that's the percentage decimal of the growth factor that I see right there. What percent did we just go up? 9.3. So you just put your decimal in the wrong spot. 1.93% increase. So we're going up by 9.3%. Now, what you need to pay attention to in this question is that the year 1995 is the starting number, the starting year. So we're going to call that an x value of 0, and yes, that should be written in your notes. The x value 0 represents the year 1995. So, what x value do you think we should use for 1999? 4. That is correct. Because it is 4 years after 1995. And they're just saying that they collected the data from 1995 through 2006. So it will not play into either answer A or B. Okay? So you've got an equation. You've got the x value. Find it. Follow the equation. 84,193 It is year 1995. They didn't ask me about year 1995. They asked me about 2009. good choice on what year you picked, too. Okay, so 121,198. Now, 2019. What X value would that be? 2019. What is the X value for that? It's more than 20 because this was a 4 and you just went up 20. 24 years. Now, if you want to, you could always say 2019 minus 1995. That's going to give you 24 also. Too much. Oh my goodness. Now don't hurt me with those 0.5s. Yeah. These are people we're talking about. 717,627. Okay, question 4. The formula gives the number of cell phone users in millions. Folks, that's important right there, in millions. So what does this 17 number represent? That's 17 million people. So what year did that start? 1994. They were kind enough to tell me that X equals 0 is 1994. So, before you were born, there were 17 million cell phone users. Yeah, million. Okay? Now, what percentage increase are we talking about in this? What percentage increase? That's a 22% increase. That's growing quickly. 2008. What X value should we be using? What X value should we be using if the starting value was 1994? That's 122%. So that must mean it went up 22%. Yes, we could talk about the vegetable okra, or you could just subtract these 2 years. Yeah, right up there with. Okay. Yeah, you grab the trash can as you go throw up. Okay, 2008 minus 1994. How many years are we talking? 14. All right, so that's my X value there. You've got your equation. Start typing.
That's why I came up with it. Wow.
275 million. Would it be okay in this particular case if somebody put 275.1 million?
No, that's not okay.
Sure is. I can deal with fractional numbers of millions of people. I cannot deal with fractional numbers of individual people. Okay? That's just sick. Okay? But we can do fractional amounts of larger groups. At least we're not hurting people. Okay? Find the number of bacteria. Find the number of bacteria. You got the equation. Times 2 to the 6. Mr. Manko, what'd you get? Nothing. We're typing that on our calculator. They gave us a formula. They told us how many days. 6 days, right? You are correct with the 256. Okay. You will not have to memorize these formulas. They will be given to you each time you need them. Okay? But I do need to go through and explain what you're looking at. We may or may not actually answer this question today because I've got a lot of explaining to do. Okay? Trust me, it will. Okay? We'll start by identifying the different pieces in here. Okay? These are both versions of this equation, y equals ab to the x. Both of these equations are. Now, what do we know about the letter a in the exponential model, y equals ab to the x? It's the starting amount, right? These two formulas that you see here with the a's and the p's are going to be used with compound interest. The one on the right has various other possibilities, but the one on the left is used for compound interest only. So the P right here and right here, those are both references to the starting amount. The word that they use to would be principal. That's why they use the capital P. That's your starting amount. A, capital A here, is the amount after T years. Can you guess what T is? Ah, yes, time in years. Now, could I ask for, how much interest would be gained after 6 months? Sure, I could. But I'm not going to do that to you because you'd have to convert 6 months into a fraction. I don't know. Some of this will make more sense to you guys. And then it'll be easier to get the questions. The time will be in years, and I'll stay in years. I won't try to trick you and throw it in months, okay? Since this is a banking situation, what do you think R represents? That is your interest rate. Thank you very much. Interest rate. Now the last thing I see in the formula on the left that we haven't talked about is n. N represents your compounding factor. N represents the number of times in a year that I'm going to give you your interest. For example, I could give you your interest once a year. One payment a year. Or I could split it up into 4 payments and give you 4 smaller payments. Or I could split it up into 12 smaller payments and give you 1 every so often. Or I could split it into 365 little pieces and give you 1 every so often. Is there an advantage to having a larger compounding factor? Yes, that's why Albert Einstein said this is one of the most amazing things he's ever seen. So, if we use the term annual, it's compounded annually, that would be an n value of 1. What do you think we would be using if we were talking quarterly? 4, right? There's 4 quarters in a dollar. Now I know this is not paying you money, but there are some companies that really like to compound monthly. Who charges you on a monthly basis? They absolutely do. Of course they do. Okay, what would be the end value if it's monthly? 12, and who loves to charge you monthly interest? They're plastic. You might find them in your wallet. Credit cards, right? If you don't have one, eventually you'll be dealing with them. No, you don't have to. I like them for the free points. We pay them off every month, so there's no interest. I never pay interest. I am a deadbeat customer to a credit card company. They really look at me as a deadbeat because I have a great credit score and I never pay them any money. But unfortunately, there are way too many other people that pay them a lot of money. Okay, so if there's only one more that I'm going to add to this list, and it is daily. What do you think the end value is for daily? 365. Now, why is it to your advantage to split your interest payments up into smaller amounts and get them more frequently? Because you get interest on top of interest on top of interest. You make more money. And I might erase a little bit here. Some of these lines I can erase so I can show you something else. Okay, now I originally told you that these two functions were exponential functions. I'm going to show you here in a minute after I talk to you. Okay, there it is. The part that I'm kind of circling there in the purple and this part in the purple are going to eventually equal each other, but let me discuss it with you. So, I forgot to write down the name, sorry. Thank you. Okay, so, sorry, I'm concentrating. Right now I'm like orange juice.
Right now I'm in November 2019.
Okay. So, there was this mathematician, super nerdy guy named Leonard Euler. That's his last name right there. Not Euler, Euler. Okay? So, Leonard Euler's he said, let me use this compound interest formula. I'm going to look at what happens when I invest $1 at 100% interest rate. Now, 100% interest rate means you're doing what? You're doubling your money, right? And he's only going to do it for 1 year. $1, 100% interest for 1 year. And he said, well, what's going to happen if we increase that compounding factor? Okay, super nerdy guy, so he's throwing in all these numbers, right? Starts out, so if you just do it for compounding factor of 1, you get $2. Okay, well then when he started to raise the compounding factor, he found out that it was getting higher and higher and higher and higher and higher, but it was slowing down, which means it was reaching some maximum value as he kept going. He found out that it was 2.718, blah, 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 blah. It was an irrational number that kept going on forever, never stopped, and never repeated. So they decided to name it after him. And they used the first letter of his last name. They named that number E. So, in every one of your calculators, this number is programmed into it. Okay, now I'm only going to write it out to the thousands. Please, on your calculator right now, find the LN button, because the LN button has right above it e to the x. Make sure you can find e to the x on your calculator right above the LN button. Anybody not find the LN button? Right above it should say e to the x. We will eventually be using that button, okay? Now, when you come in my room the next time, you will look at my sign as you walk in the door. It says this. What does that say? Mr. Stale E, thank you very much. Okay, so now you know what it says. Now you know what it says. I should put that outside my classroom? Are you kidding me? It already is out there. It's been out there the entire year. It's been out there for a long time. Like, it could have been even before you were born. I don't know.
I saw it. I didn't know what it meant though.
That's right. Now, with the EY, oh, okay, that's a good idea right there. Thank you very much. I just went phonetic, but that's nice. It's nice. Why don't you pay attention? Now, without trying, hey, you should change your calendar. Hey. All right, so these two purple boxes or purple areas that I have circled, as n gets higher and higher and higher and higher and higher, that becomes that. And so one of the formulas comes from the other formula. Now, when are we going to use the formula on the left? If there's a word in our problem that comes from this list right here, you'll be using the formula on the left. What phrase are we going to look for to use the one on the right? The phrase you'll be looking for is compounded continuously. Please make sure you have this written down. Compounded continuously. I know. Came from a different source. Compounded continuously goes with that other formula. So when you look at this particular question, number 6, since we do have a minute or so here to work on at least this one, we'll see if we can get to the next one. we can see that they use the term compounded annually. So I know we're going to be using the one on the left. How much are we starting with? So that's our p-value, 16,000. And then we have 1 plus something. Since the compounding factor is a 1, I can replace both of those n's with a 1. How much time are we talking about? 7 years. What are we going to put in here for the interest rate? Are we going to put the whole number 12? No. 0.12. 0.12. Please do not put 12. You will have a huge number there and not know why. Now I've got a question for you. Since the n value is a 1, do I need to worry about typing it? Or could I just type 16,000 parenthesis 1.12 to the 7th? Is this the same thing as what I have written below? Okay, but if you take 0.12 and divide by 1, what do you get? It is the same thing. Now, that's only true if we're talking about annual compounding. You pick one of those other compounding factors, it's not going to be the same, so don't do this. This only works because n is 1. If that's a 4 or a 12 or a 365, that's going to drastically change your answer. So, stick to this, unless, you can only use this because of this case being an annual interest. We have the answer? What is it? That would be letter B. Can I get a witness on that? Okay. Alright. And before we go, tell me what compounding factor we're going to use on number 7. What compounding factor are we going to use on number 7? We're going to use n equals 4. Now, I do want you to realize something, folks. You see that I changed the problem? None of those answer choices, A, B, C, or D, will be correct. Because those are all based on the word that was printed annually. I changed the word to quarterly. So don't look at this and go, I don't see the answer anywhere. Great. You shouldn't. We'll finish that up tomorrow.